Hello pre-calc students, I am Mrs. Mueller. I'm one of the math teachers at Armstrong High School, and welcome to your first lesson. This is 1.3 graphing linear functions. 1.3 corresponds to the chapter and section in your textbook. We are skipping 1.1 and 1.2 for now and just hopping into 1.3. So here we go. Pause as you need to and write down the things you need to. First thing we're going to do is just evaluate some functions. If you've gotten to pre-calc, you have probably done this many times, but just so that we're all on the same page and I'll have some common starting ground here, we're going to do a couple examples. So first example says find f of negative 1 if f of x equals 3x to the third power minus 2x squared minus 2x. So this function notation just tells us that what's inside of the parentheses here, this negative 1, that's going to get substituted in for every x that we see on the right-hand side of the equation. So 3 times this negative 1 is going to get substituted in. So f of negative 1 is 3, and then we have our first x. So there we can see we've substituted in negative 1 3 times for all 3 x's. Okay? Then what you want to do is follow through with your order of operations. So parentheses, not really any parentheses to deal with their exponents. We do have. So what we're going to want to do is deal with this and this. So negative 1 to the third power. Negative 1 times negative 1 times negative 1 ends up being negative 1. And then we have negative 1 squared. Negative 1 times negative 1 is positive 1. So that becomes just a 1. And then we can just copy down the rest of the equation. Negative times negative is a positive. We can clean that up, I guess, while we are at it. And then at that point, we just need to do our multiplication. So 3 times negative 1 is negative 3 minus 7 plus 2. Negative 3 minus 7 is negative 10. Negative 10 plus 2 is negative 8. So our final answer there is negative 8. Okay? Second example. Find f of c minus 5 if f of x equals x squared minus 7x plus 4. So same idea, except this time we have a little more than just a constant. We also have a variable, but treat it exactly the same way as we did in the first example. Just take this c minus 5 and substitute it in each time you come across an x. So f of c minus 5 is equal to, I see an x, I'm going to replace it with c minus 5, make sure it gets squared, minus 7 times c minus 5 plus 4. Okay, now this is a good little review of some algebra stuff. If we want to deal with c minus 5 squared, it's an exponent, we need to deal with it. We cannot just square the c and square the negative 5. That doesn't work. C minus 5 squared really means c minus 5 times itself times another c minus 5. Okay? So we need to make sure that we deal with that. So I'm just going to write down the rest of our right-hand side. Okay? Some of you probably learned FOIL, first, outer, inner, last. Some of you might have heard the term double distribute. Either way, we just need to make sure that when we're multiplying a binomial by a binomial, that the c gets multiplied by the c and the minus 5 in the second set of parentheses, and then the negative 5 also gets distributed onto each of those. The order that you do it in doesn't really matter. But what we're going to come up with is c times c is c squared. C times negative 5 is negative 5c. negative 5 times c is negative 5c, and then negative 5 times negative 5 is positive 25. And then I'm just going to keep on going. We need to distribute this negative 7 out. So negative 7c plus 35, and then plus 4 at the end. Okay, at that point, it's just a whole bunch of combining like terms. So the only squared that we have, or the only squared that we do have, is this c squared. Then we're going to look for all the terms that have a c in them. So we have negative 5, negative 5, negative 7. And that is going to give us a grand total of negative 17c. And then lastly, all of our constants. We have 25 plus 35, which is going to give us 60, plus 4 more, plus 64. And that's our final answer. All right, now we need to go through a couple different forms that we might run into for our equations. First one is standard form. ax plus by equals c. If you are graphing an equation that's in standard form, that's our main objective today, is graphing, and you can see that right here. Couple steps that you can take if you're in standard form to make things easy for you. First step is to find the x and y intercepts. Find the x and y intercepts. You can do that by doing this. Your x-intercept is found when y equals 0. Okay? So you can replace your y with a 0, and then you can figure out from there what your x-intercept is. Do the same thing for y. Your y-intercept happens when x is equal to 0. So you can substitute 0 in for x, solve for y, and that will tell you where that y-intercept is located. Okay, at that point, super simple. You are just going to plot those 2 points and connect those 2 points. Slope-intercept form. If you get an equation in slope-intercept form, it's your lucky day. That's the easiest, in my opinion, easiest form to deal with when you are graphing, and that's probably the one that you're most familiar with. So the steps for that is you want to start by plotting your y-intercept. And your y-intercept happens at your b. So on the y-axis, you are going to plot your b wherever that might be. Second step is use your slope, and that's your m, to find the next point, or to find another point. Now you have 2 points, connect, and make a straight line. Okay? Point slope form is another one that we're going to come across from time to time. Okay? Big thing here is when you are going to kind of take the shortcut here and plot or make a graph directly from slope-intercept form, you want to make sure that you are plotting the point opposite of x and y. Okay, so you're going to look here and here. You're going to turn that into an ordered pair, but you're going to use the opposite of what you see. And we'll go through an example so you'll see what I mean there. Okay. After that, same as what you did in point slope form, you're going to use your m, your slope, for your second point. And then obviously connect those 2 points. Alright, last thing we just need to talk about really quick is what a linear function is. Obviously, lines are functions. You're not going to come across a line that is not a function. But the key here is just being okay with function notation. So f of x is the exact same thing as y. So if you ever see something in function notation like that, it doesn't really matter. You can change the f of x to a y, and it means the exact same thing. And that's probably the most common way that you're going to see a function or an equation written for a line, is the y equals mx plus b. Okay, slope. This stuff should be familiar to you, but once again, it's day one. We're just going to go through and make sure that we're all comfortable with this. If you are looking to find a slope, you can always compute the rise over run. You've probably heard that a lot. If you have ordered pairs, y2 minus y1 over x2 minus x1. So I always kind of remind myself that this is the rise, or the up and down, over the run, or the side to side. Okay? And if you were given 2 points, say you had 7, 2, and you had 6, negative 3, this could be your x1 and your y1, your x2 and your y2. That's where those are coming from. Okay, just a random example there. X-intercept, that's where your graph crosses the x-axis. Okay, that's always going to happen when y is equal to 0, and I already mentioned that earlier. So you're going to have an x value, and then your y value is going to be 0 every single time. Your x can change, but your y is always going to be 0. The y-intercept is the same idea, only the opposite. It's where your graph crosses the y-axis. So your x is going to be 0, and you're going to have some ordered pair, which is 0 every time, 0, comma, and then some y value, depending on where you are. 0. Your 0 is found exactly where your y-intercept is found. These are basically the exact same thing. These are basically, what do we want to call them? They're the same, okay? So solve for x when y equals 0. So set y equal to 0, solve for x. Or if you're in function notation, you want f of x equal to 0. So not f of 0, but f of x equal to 0. Alright, let's jump into some actual graphing examples. For your notes, obviously they're your notes, so you can do what you want to do, but if you have some graph paper, that would be excellent. Otherwise, just try to stay as organized as you can here. Okay? So we're going to graph 2x minus 3y equals 12. So we are in standard form here. We are in the ax plus by equals c realm here. So ax plus by equals c. So standard form. So if we're following our steps from earlier, what we want to do is we want to find the x and y intercept, and then we just want to plot those points and connect them. Okay? So our x-intercept happens when y equals 0. So I'm just going to say 2x minus 3 times 0 equals 12. We're just setting our y to 0. Negative 3 times 0 is obviously 0, so that's gone. So 2x equals 12. X is equal to 6. So our x-intercept happens at 6, 0. X value 6, y value 0. Our y-intercept is when x is equal to 0. So we're going to set x equal to 0. That's going to go away. Divide by -3. And y is equal to -4. So the point that we need, x is equal to 0. We set x equal to 0. Y is -4. So now we can go over to our graph. 6, 0 is our first point. So we want to go over 1, 2, 3, 4, 5, 6. And then our y-intercept is down 4. And then you just want to be as neat as you can. Draw a straight line through those 2 points with arrows on both ends. Okay, so if we are identifying the x-intercept, we kind of already did the work for that up above, but our x-intercept would be at 6, 0. Our y-intercept is at 0, -4. And then the slope. How do we figure out what the slope is? Super simple once we already have it graphed. Remember, your slope is rise over run. So how far up did we go? 1, 2, 3, 4. And what was our run? 1, 2, 3, 4, 5, 6. So 4 over 6. Which ends up being 2/3 once we reduce. Alright, second example. X plus 2y minus 4 equals 0. Technically, this isn't in any of the forms that we talked about, but it looks most similar to standard form again. The only problem is this minus 4, our constant, is on the wrong side. So we can easily fix that by just adding 4 to both sides. So x plus 2y equals 4. Okay? Identify the x-intercept. Remember, that happens when y is equal to 0. So x plus 2 times 0 equals 4. X equals 4. That's pretty simple. And then your point is at 4, 0. For the y-intercept, we want to set x equal to 0. So 0 plus 2y equals 4. That's pretty simple. 2y equals 4. If you divide both sides by 2, you get y equals 2. So that one is at 0, 2. All right, and then I'm just going to plot those 2 points. So 4, 0 over 4, up and down 0. Your y-intercept is at 0, 2. Draw as straight of a line as you can through there. And then slope, down 2, right 4. So -2/4 or -1/2 if we reduce. All right. Kind of an easier one coming up here. This one is very nicely in slope-intercept form. This is your y equals mx plus b form. So a little bit easier to identify things. What I would do in this case is I would go ahead and graph it first, plot your y-intercept, use your slope, and then find your x-intercept and your y-intercept from there. So my y-intercept is right here. So we're going to plot 0, 4. Right there. Slope is -1/2. So from this point, we want to drop down 1 and to the right 2. And I'm just going to keep doing that. Until I can see where my y-intercept is, or my x-intercept, excuse me. There's our line. So now we can pretty easily answer the questions below, or identify the things below. X-intercept is right here, where our line crosses the x-axis. looks like it's to the right 8 and up and down 0. Y-intercept, that was really easy to find right from the get-go. That's our B. If you want to write that as an ordered pair, it would be 0, 4. And then the slope, negative 1/2. Next example, y minus 2 equals negative 1/4 times the quantity of x minus x1. This is our point slope form. So we can identify a point from here. Our point is going to come from these numbers here. And then our slope is going to be easy to find. That's why this is called point slope form. So before we get to identifying the x-intercept and the y-intercept, we can jot down the slope. That's really easy, negative 1/4. What we do need to do, though, is we need to identify that point. So this, again, our point, we want to use the opposite of what we see. So for our x value, we want to use the opposite of positive 1, which is obviously negative 1. And we want to use the opposite of negative 2, which is positive 2. So our point that we need ends up falling at negative 1, 2. So opposite. That's a big thing to remember here. The opposite of what you see. Your x value is the opposite of what's next to x. Your y value is the opposite of what's next to y. Okay? Now you have that point, so you can go left 1 and up 2. And then use your slope, negative 1/4. So down 1 over 4. And do it one more time. Try to draw a straight line. Now your x-intercept is pretty easy to identify. It looks like it is over 7. 1, 2, 3, 4, 5, 6, 7. Yep. And your y-intercept is not very easy to see there, is it? Not an easy one to see. And I actually don't think at this point that's not our biggest concern right now. So we are not going to worry about answering that question right now. There obviously is a way to do it, but we have enough to tackle right now that we're just not going to worry about that one right now. Okay, couple just oddball ones to take care of. Graph y equals 3. I don't know if you remember this from previous years or not. I always just remember that if all I see is a y, in my head, I'm thinking, oh yeah, the y-axis is the vertical axis. But when you're graphing the line y equals 3, it's actually the opposite of vertical. It's positive. So another way to think of it is go on your graph and find somewhere that has a y value of 3. Well, I know right here, that's a y value of 3. That's at 0, 3. Find another spot that has a y value of 3. Oh, how about over here? That one has coordinates 8, 3. So the y value is 3 and the y value is 3. And now, oh yeah, a horizontal line, not a vertical line. Okay? So if we are identifying some things here, x-intercept, there is not one. That horizontal line is never, ever, ever going to cross the x-axis. So there is no x-intercept. Y-intercept, definitely. There definitely is one. It's right here at 0, 3. And then slope, well, if you are trying to go from this green point to this green point I just drew, you are going up and down 0. So your rise is 0. Your run is, in the case that I have up there, 8. 0 divided by 8 is 0. So your slope is 0 in this case. Just a flat line. Okay, x equals negative 4. Since we just talked about the y equals situation, the x equals situation is pretty simple, I think, to grasp. You just need to find a spot where x is equal to negative 4. So if I go back 4, There's a spot where x is equal to negative 4. Here's another spot where x is equal to negative 4. Here's another spot where x equals negative 4. You got the idea. So x equals negative 4 is this vertical line. Vertical line. X-intercept, there definitely is one in this case. It's at negative 4, 0. Y-intercept, there is not one. And slope. Okay, here's kind of the tricky thing here. I'm going to pick these two blue dots. Okay, and if I do rise over run, the rise in this case is 1, 2, 3. The run is 0. We don't go left or right at all. Okay, that's a problem in math. If you try to do 3 divided by 0, it doesn't work. Your calculator will say error or undefined or something like that. Okay, so I would say that this slope is undefined. Okay, it's not 0. It would be 0 if it was a horizontal line, but a vertical line has an undefined, impossible slope. Alright, last thing, we're almost done here. Zeros of a function, we already talked about this a little bit. It is the exact same thing as an x-intercept. So it's the values for which f of x equals 0 or for which y equals 0. Same thing. Same as finding the x-intercepts. So if you are going through these, you could certainly use a graph and graph them and figure out what they are, or you can just use algebra and figure it out that way. So I'll do it both ways just so you can see it, but totally up to you how you do it. If you were doing it by graphing, our first one is in slope-intercept form. So your intercept is at negative 4. Your slope is negative 1. So there's your graph. And all you are looking for is that x-intercept. It's right there at negative 4, 0. Okay, if you didn't have a graph and you just wanted to do it using algebra, that's totally fine too. You would just replace f of x with a big fat 0. So 0 equals negative x plus minus 4. And you would solve for x, get x by itself. Super simple. Just add x to both sides, and x equals negative 4. And then you could throw that into an ordered pair easy enough. Negative 4, 0. So same answer, 2 different ways. Doesn't matter to me. Second one, if you do it using a graph, remember this is the same as y equals, so y equals negative 2. And remember from earlier that that's going to be a horizontal line. If it's a y equals, it's horizontal. And if we are looking for an x-intercept, we are not going to find one. Not possible. None. None zeros. None x-intercepts. If you were doing it algebraically, you'd see that you'd run into the same problem rather quickly. If you replace y with a 0, you're going to end up with 0 equals negative 2. Not a thing. 0 is not negative 2. Okay, another way you could write this is no solution. Alright, that's it for the lesson. Your homework or your practice, however you want to view it, obviously you're at home, so I guess it would be considered homework either way, is worksheet 1.3. You can find it on Schoology. You can print it if you can. You can use Kami if you're comfortable with that. You can use your notebook. Doesn't matter. You find a way to do it. Obviously, we wish that we could hand you the worksheet, but that's not really a reality right now. So use what you have at home. I'm certainly not going to be fussy about how you get it done. There are some graphs on there. Just make sure your graphs are neat. That's the only requirement. If you have graph paper, great. If you don't, you can use your notebook and just make it as neat as possible.